Okay, guys, continuation from double replacement. What I want to do right now is just go through a couple of practice examples for you in double replacement. So we'll continue a little double replacement, just two quick examples just to show you how to do it from scratch. Okay, and then we'll finish up with our last reaction, which is the fifth reaction, which is combustion, which is fairly simple. All right, so just to really go over quickly, we're going to do a double replacement reaction here. So DR. We'll do a quick one. Find a piece of paper, or maybe on the page where the combustion reactions is. Maybe below that is some extra space. Well, let's just say we had sodium carbonate, Na2CO3, and we're going to react that with silver nitrate. All right. So these two, of course, are both soluble according to table F. Sodium is a group 1 that's always soluble, and then nitrate's always soluble. So these compounds are soluble. And we're going to pour them together. All right, so we would have sodium would be a +1. We'll put make sure we put our charges down so we know what we're dealing with. Okay, so sodium is a +1, carbonate's a -1, Ag is a +1, NO3 -1. Okay, and again, what we want to do is make sure, number one, that we're using the charges for those elements as if they were single. We're not going to worry about the 2 here. Okay, so now the Na is going to take the NO3, and the Ag is going to take the CO3. So we're going to create 2 new compounds. So we're going to take Na plus and NO3 minus, and we will crisscross those 2, and we will end up with NaNO3. Again, notice that I did not take over the subscript. I did not carry that subscript over. Remember, Na is 2 when it's with carbonate, but we don't know what it's going to be like when it goes with nitrate. So we're just using the single sodium. We will balance it later, okay? That's the correct formula for sodium nitrate. And now we're going to get silver and carbonate. So we should get silver up here +1, carbonate 2 minus. Okay. And again, we're making sure we put the silver first because it's positive, and then we're going to crisscross. 2 comes down here, and we end up with Ag2CO3. And then the next step, what we want to do is check table F and see if we have an insoluble solid here. We're looking for the insoluble solid. Okay, so if we take a look at this first compound and we look up NaNO3, we're going to find that Na is always soluble and NO3 is always soluble. So this is going to be AQ. So that's not the precipitate. Okay, so this becomes soluble. And the AQ is enough for that. Okay, and if we look up silver, we're going to find out that carbonate is insoluble. Okay, and there's no exceptions that have silver in it. So this is your precipitate. So you can put a solid. Sometimes what they also do is put a downward arrow next to it to show that it's coming out of solution. It's becoming crystals. So this becomes your precipitate. All right. Now remember, in every double replacement, you must find a precipitate. If you do not, okay, then this reaction is no reaction. Okay. So that's next. So you're looking for the precipitate. Again, it could be either one. It'll never be both. Okay. So there's 2 conditions. Either both of them will be soluble, okay, or one of them will be the precipitate. All right, and if they're both soluble, then you write no reaction. Okay, all right. And the second one I spoke about before is you don't always have to get a precipitate. Sometimes you can produce water. Okay, that's going to happen in a case such as this. If you have the hydroxide ion, barium hydroxide, and we're going to react that with HCl. Okay, so same story as before. Barium +2, hydroxide is -1. H is +1, Cl -1. Confirm those in the periodic table. We're going to do our switcheroo. Have barium take the Cl, and H take the OH. Now, interestingly enough, so we're going to take Ba. Oh, and we have to balance this, sorry. So we're going to take Na, so 2 NAs, 1 carbonate, 1 carbonate, 1 Ag, 2 Ags. We need a 2 here, 2 NO3s, and now we balance that with the 2 NO3s. Okay, so we're looking good. So we have a 1 to 2 to 2 to 1 reaction. Okay, just to make sure we balance. Okay, so back to the barium one. We're going to take this. We're going to take Cl as -1. We'll switch them. We'll get BaCl2. Okay, that we look up in the table, and we'll find out that that is soluble. Okay, so we look up that is soluble. Okay, because chloride is soluble, right? Except with a few others, but barium is not one of the exceptions. And now this is interesting because what we do, again, what we want to know is that H and OH. So interestingly enough, if you take H and OH, that actually is a water molecule, believe it or not. Think about that. So if you take H and OH, if you look at these two, when you put them together, remember that's your water molecule. There's your OH, right? And there's your H. There's your minus, and there's your plus. All right, so if you put them together, you get water molecules. Now, water molecules you did not have before, and water is a liquid. So this kind of acts as your precipitate, but we're not going to call it a precipitate. We're going to call it just water. All right, so because water is produced, this reaction takes place. All right, so again, according to the list, we have three things that can happen: a precipitate, a gas, or water. One of those three things must take place in a double replacement to confirm that the double replacement has, in fact, occurred. All right, so we're going to take H and OH. Now, a little trick here. Again, one H and one OH will form one water molecule. In this case, we have two OHs, so we're going to need two H's to make that two water molecules. Right? So you can just, by balancing the waters, we balance then the rest of the reaction. So one BA, two OHs and two H's make two waters, two Cl's, we're all good. All right, so those are two types of reactions that would produce a reaction, okay? The third one, we can do one more, is we can say, let's just say we had sodium nitrate, okay? And then we had potassium chloride. We wanted to mix those two, all right? So again, +1, -1, +1, -1. We get our charges, make sure you know your charges, and we'll take Na and Cl and K and NO3. But we find something really interesting about this. When we go to create our new compounds, and we take Na, right, that would take Cl, we find out that this has Na in it. So Na and Cl, that's aqueous, right, because that's soluble. Na is always soluble, all right? And then we take a look at the next one. We have K and NO3, and again, K is group 1, so is Na, and nitrates are always soluble. So this produces two AQs. So if this is soluble, whoops. All right, guys. Screwed up. If this is soluble, so we NO3O plus KCl, right? If we had NaCl plus KNO3, and this is soluble and this is soluble, then we can't even write a reaction. So really the example is no reaction in that particular problem. All right? So again, if you produce two solubles, then there's no reaction. You can see this from time to time. All right, so that takes care of that. Last reaction coming up is called a combustion reaction. Okay, and a combustion reaction is when you take any CH compound, or any CHO compound, and then you add it to oxygen. Okay, you always produce carbon dioxide, water, and energy. Okay, so this is one of the few reactions, again, out of the 4 or 5 reactions we're doing, this is the only reaction where you always form the same products. So this is the easiest of the 5. Okay, in fact, it's so easy that people forget about it and they get it wrong. So this is any CH compound or any CHO compound will produce carbon dioxide and water. So some good examples. Now, CHs will be called hydrocarbons, okay? And CHOs are usually alcohols and sugars. Again, a typical alcohol would be CH3OH would be an alcohol. C6H12O6 would be a typical sugar, okay? Maybe C3H8 would be a particular hydrocarbon, or C20H42, anything along those range. So if you take a look at this propane reaction, propane is C3H8. Again, we'll always have to, don't forget to add the oxygen to this. Okay, you always get CO2 and water. And again, you have 3 C's, we'll have 3 C's, we'll have 8 H's, we'll put a 4 here for 8 H's. We got 6 plus 4 oxygens here, okay, equals 10. So we'll put a 5 in front for that. All right. Say we had ethanol, which is an alcohol, and we reacted that with oxygen in burning. Okay, hand sanitizer typically has alcohol in it. Okay, again, notice in both of these that we're going to have carbon dioxide and water as an example here. Okay, this is a little tricky, so watch your trickiness here. We have 6 hydrogens here. Don't say it's 5. We actually have 5 plus the 1 is 6. So if 3 works well there, okay? We have 2 carbons here. We'll take 2 carbons here, all right? And then we'll count up our oxygens. We have, let's see, we have 4 oxygens here, and we have 3 oxygens here, which is 7. So we're not looking too good because 7 is not an even number. And we have 2 here, but careful, there is an extra oxygen here. So we can make this 6. We can add that 1 and make it 7. So that would be a 3 here. So that would be 6 plus the 1 is 7. So you get 1, 3, 2, and 3. Okay? So that's it on combustion. Really easy, no tables, no charts, no worries. And that's pretty much it. So make sure you have to look back at those double replacements. Do that again to help you way through it. And from that, we're on. Take care.